Hi guys, good evening everyone. Good evening guys, how are you all? I hope everyone is doing well. So I'm so sorry guys, we started a little late due to some technical issue. So yeah, what we'll be doing today is we'll be discussing about colligative properties from solution. So last class when we met, we discussed two colligative properties. One was depression in freezing point and relative lowering of vapor pressure. So we discussed about these two colligative properties in the previous session. Those who have not watched it or those who have not seen it, you can go and check the previous video as well later on, but no need to worry. The colligative properties that we are going to study right now, it's not like nowhere related as such. You will be able to understand even them also, okay, very easily. So for all the new learners, those who are here for the first time, for all of them, let me just quickly introduce myself. So, hello everyone, I am Manisha, your chemistry educator at Unacademy, and I have enriched 5 years of experience in online and offline teaching. I have done my master's from NIT Warangal and bachelor's from Delhi University. And I have cracked IIT JAM, CSIR NET, and GATE. I have given best ranks through my student, and I'm a plus verified tutor, guys. So, yes, this is about me. So, though all those who are here in the session, I want even them also to introduce themselves. Yes, those who are new here, so that I'll be knowing about them. And now let's just start with the topic, guys. Okay, so yeah, what we have to discuss is we have to discuss about elevation in boiling point. That's the colligative property. So I hope everyone knows what are the colligative properties. Colligative properties are nothing but the properties which depends only on the, yes, total number of solute particles to the solution particles, not on the nature of it, right? So we are talking about elevation in boiling point. This is one of the colligative property only. I hope everyone knows there are total four colligative properties, and yes, out of these four colligative properties we are going to discuss two today. And yeah, let's just discuss that. Okay, so just a second, guys. Those who are here watching, I'm not able to see your chat. Um, okay. Okay, so what we'll be doing is we'll be discussing about first is elevation and boiling point. So talking about elevation and boiling point, as the name itself is saying, boiling point is going to get elevated. So first of all, what is the boiling point? What is the meaning of boiling point? Everyone can define. So most of the people, they'll be saying the temperature at which a substance, a liquid boils is the boiling point, right? But if we talk about exactly what it is nothing but, guys, yes, it is it is the temperature at which yes, the vapor pressure the vapor pressure of the liquid becomes equal to the external pressure, okay, which is nothing but atmospheric pressure. So what is boiling point? The temperature at which the vapor pressure of the liquid becomes equal to the external pressure, which we can also relate as atmospheric pressure surrounding the liquid. So this is basically called as boiling point. So yeah, like in general, most of the people, they just say that it's the temperature at which it's at which a liquid boils, right? This is also to the extent it is correct, but all of you should know that technically, if we talk about boiling point, is nothing but it's the temperature at which the vapor pressure of liquid becomes equal to the external pressure. Okay, very good. Now talking about the next thing, what we can relate is, yes, that what happens when you add a non-volatile solute to a volatile solvent. So remember that in all the colligative properties, what we do is when we add a non-volatile solute to a volatile solvent. So what happens? What we have observed, that the boiling point of the solution increases, right? So in this case, what we have seen, the boiling point increases. The boiling point increases. Okay, so when we add non-volatile solute to a volatile solvent, boiling point increases, and that's what we can relate. Now, if I talk about what we can understand here, guys, a simple, that when boiling point increases, so how we can interpret that? So we can find it out, the change in boiling point. So how we can find it out, change in boiling point? Yes, how much elevation in boiling point has taken place, so that we can find it out, TB minus TB naught. What is TB here, guys? It's a boiling point of solution which has increased. So that's the final one, boiling point of solution. And what is TB naught? It is nothing but it is the boiling point of solvent. Boiling point of solvent. Okay, so this is the boiling point of solution, this is boiling point of solvent, and this is how we can find it out, the change. Okay, but what we have seen, no, that the delta TB is found to be directly proportional to molality. Delta TB is directly proportional to molality. So what I can do, it's simple, delta TB, wherever will be solving any question, if proportionality sign will be remaining, we won't be able to do the numericals. So we have to introduce some constant. So delta TB is equal to Kb dot M. Okay, so what is Kb here? Kb is nothing but Kb is molal. Kb is what? Molal elevation constant, or even it is also known as one more name, ebullioscopic constant or ebullioscopic constant. Okay, so it is called as molar elevation constant or ebullioscopic constant. Now, Kb, how we can write it? So Kb is equal to nothing but R into Ma. How we calculate, how we get to know? So it's an experimental quantity. So the formula of this is R into Ma, which is the molar mass of solvent, Tb naught, which is solvent boiling point, divided by 1000 into enthalpy of vaporization. Simple. So this is how you can calculate experimentally. How you will get the experimental thing? Obviously, boiling point you are going to get to know experimentally. Enthalpy of vaporization you are going to get to know whatever substance you have taken, that's molar mass you can understand, and R is universal gas constant, so we can write about it. So what and all things we have in this formula? So R is universal gas constant. What is Ma? M is the molar mass of solvent. Ma is molar mass of solvent. Correct. What is Tb? Tb is boiling point of solvent. And what is delta H vaporization? Just enthalpy of vaporization, guys. Very simple. Enthalpy of vaporization. Okay. So by this way, what I can do is I can find it out easily. Yes, I can find out easily the what I can do is I can find out easily the value of Kb. So most of the cases, guys, you don't have to find out the value of Kb. You just have to, like, it will be given in the questions, right? But yeah, we require, yes, we require these values so that we can find it out, the Kb, if any time we get the question like that. But yeah, mostly it will be given. Okay, now if I talk about what we can relate, it's very simple. Do you know what is molality? How we can write it? So delta Tb is equal to Kb dot molality we can write as given mass of solute divided by molar mass of solute into 1000 divided by mass of solvent in gram. Okay, so this is the whole formula which I can utilize for the elevation in boiling point, how much it has taken place. So this we can understand easily with this formula, which is delta Tb is equal to Kb dot Wb by Mb into 1000 divided by mass of solvent in gram. So let's just discuss one question related to it, so that all of you will be understanding that how we'll be implementing this formula and how we'll be getting the questions related to it. So let's just quickly discuss that. Okay. So the question is, yes. So remember, they can give you anything to calculate over here. When you have a formula in that some few terms are involved, right? So you can relate that suppose five terms are involved, four terms are given, fifth term you can calculate by just equating it here and there. Okay, so it's very simple, guys. You don't have to be worried that how it is going to be. Is it like whether what I have to calculate? It's very simple. Just read the question properly. You will get to know what and all things are given, and accordingly, you can just put it in the formula and you can get the answer. Okay, so let's just discuss one question and let's see who and all will be able to solve that. So the question is boiling point of water. Boiling point of water at 750 Hg. Hg is 99.63 degrees Celsius. How much sucrose is to be added? Sucrose is to be added, yes, to 500 gram of water. To 500 gram of water, such that it boils at 100 degrees Celsius. Such that it boils at 100 degrees Celsius. So how you can interpret this question? It's very simple. They said you do the water boiling point at this pressure is this much degrees Celsius. Now they're saying how much sucrose you should add so that it will become 100 degrees Celsius, so that it elevates. You can see that whether it is increasing with the margin value, but it is increasing, right? It is elevating. So what we can understand here, so all those who are here, guys, I'm sorry, but I'm not able to see your chat suddenly. There is some technical issue here. Okay, so if you will be having any doubts, you can just post that in the comment section, and I'll be just getting to know after the session, not in the live chat. Later on in the comment section you can put, so that I'll get to know. But there's some technical issue, I don't know, but I have just opened the link again and again, but I'm not able to see the chat of you guys. Okay, so if you have any queries, anything, you can just put that and let me know. Okay, so yeah, what we have got to know, a simple thing, that I have to calculate how much sucrose is to be added. So I have to calculate the amount of solute which has to be added. So you know the formula, delta TB is equal to WB by MB. Like before that, obviously there is a KB, right? So this we are writing molality. So yeah, what you have is KB into WB by MB into 1000 divided by mass of solvent in grams. So can we calculate it, guys? Yes. So first of all, you must be thinking that KB is not given to us, right? And if KB is not given to you, you won't be able to calculate, right, the correct answer. So first, if KB is not given, okay, so first of all, it will be given. I'll be giving you KB, but I wanted you guys to recognize that KB is not given, because always you have to check with the question what and all terms you require in the formula, and then check what and all things are given. And is there any other way by which you can calculate that term? Because that is also possible. They can give you some term which can be calculated by some other small formula, but for that also that value should be given to you. Okay, so talking about it, yes, we have KB value I'll be giving you. Then WB, yes, I have to calculate. MB of sucrose, how much sucrose is to be added. So what is sucrose? C12H22O11. Mass of solvent in gram added to 500 gram of water. So this is given 500. Okay, so I have to calculate WB. So if KB is given, but before delta TB, can I calculate? Yes, we can calculate that. Everyone, I hope you remember delta TB is equal to TB minus TB naught. Boiling point of solution minus boiling point of solvent. So you have boiling point of solution. Yes, I hope you can relate that. Sorry, it got scrolled to the back. So you have here the boiling point of what, guys? Boiling point of solution, 100 degrees Celsius is given in the question, and for solvent it is given 99.63 if I'm not wrong. So it is given. I can find it out. And by that you can, yes, quickly solve it. So it's very simple. Yes, everyone got it. I hope everyone understood. It's very simple. Okay, so let's just see this question quickly. Everyone. So we have 100 minus, but before that KB value I should give, right? Then everyone will be able to calculate. So KB value is nothing but it is 0.52. KB is 0.52, so that way you can calculate. So it's just we have to find it out the answer and we will get, because we have to calculate mass of solute basically, right? So yeah, I can put all the values now. 0.52 into, but before that delta TB value also I can calculate. It's very simple. It's 100 minus 99.63, correct, which is equals to KB, which is 0.52. So it is given in the question. Always it will be given, otherwise it will be giving you rest of the values to calculate by the KB formula. So it's 0.52 into WB I have to calculate, MB, molar mass of sucrose, which is C12H22O11. Can I calculate that? It's very simple. 12 into 12 plus 1 into 22 plus 16 into 11. Easy, right? So 12 into 12 you will be just adding them, right? And you will be getting it. So 12 into 12 it will be 144. Yes, if I'm not wrong. Tell me guys, 12 into 12 it's 144. So you have to do the basic calculation only, guys. See, you will be putting this value here, MB. You will be calculating into 1000 divided by mass of solvent is 500. So can't you calculate WB? Very simple. So I hope everyone has understood. So you'll be getting around the value. Yes. Can anyone tell what will be the answer for it? Everyone? Okay. So that's what you can easily calculate it and you can get that. So you'll be getting the whole answer as 342. So you'll have put 342 here, like, and you'll be just solving it and get the answer for the KB. So I want everyone to tell me the answer in the comment section, that what will be the value of, yes, what will be the value of WB according to this question. Very good. Okay, great guys. So let's just talk about the next thing, which is the next colligative property, that is nothing but osmotic pressure. So let's just start with it. Okay, so let's just discuss with the next colligative property, which is osmotic pressure. So to all the students who are here right now, so guys, I'm not able to see the live chat. I don't know, there is some technical issue. Okay, so if you have any kind of doubt, any kind of thing, you can just post the comment after the live class. Okay, I can just see that there is some technical issue. Because of that, I'm not able to see the live chat. I have just clicked on the link again and again, but I'm not able to see. Okay, so yeah, let's just start with the next colligative property, which is osmotic pressure. So what is osmotic pressure? Osmotic, all of you must have heard about osmosis, okay? But osmotic pressure is nothing but is the extra pressure which is applied to the solution side. So all of you must have heard about the osmosis, right? So in osmosis, what we do, you'll be having a container, right? Like apparatus, you can relate that, right? So how you can relate with it, let me just make it a little bit to make you all of guys understand. So suppose you have a solvent here and here you have a solution. Okay, you have solvent and solution, and this solvent is passing through a semi-permeable membrane, SPM. Okay, so how you can relate with the osmosis? So osmosis, first of all, is the movement of solvent molecules across a semi-permeable membrane from a region of high concentration to the region of low concentration. So what is osmosis? It's a movement of, we can write about it, right? So osmosis is nothing but it is the movement of solvent molecules, across a semi-permeable membrane, across a semi-permeable membrane from a region of high concentration to a low concentration. From a region of high concentration to low concentration. Correct? To lower concentration. So that is called as osmosis. It's a very basic definition, all of you will be knowing. Now what we can understand, what is osmotic pressure? So osmotic pressure is the extra pressure that you apply on the solution side. What is osmotic pressure? Which we denoted also with the pi. It's nothing but the extra pressure applied on the solution side to stop the flow of solvent molecules into the solution by SPM. That's called as osmotic pressure. So osmotic pressure we denote with pi, and how we can define that. So osmotic pressure is nothing but the extra pressure What is osmotic pressure? Osmotic pressure is nothing but the extra pressure applied on the solution side just to stop the flow of solvent molecules into the solution by SPM. Solution by SPM is called nothing but, SPM means what? Semi-permeable membrane, okay? Semi-permeable membrane. Semi-permeable membrane means the one which allows only few things to pass through it, okay? Is called osmotic pressure. So basically we'll be applying on the solution side, by which we will be stopping this flow, okay? So how we can relate with the osmotic pressure? So osmotic pressure, what we found, that it is directly proportional to concentration, and it is also directly proportional to temperature, okay? So if they are both directly proportional, so I can write pi is directly proportional to Ct. What is C here? C is concentration, okay? T is temperature. So obviously I have to remove this proportionality sign. So how I'll be doing it? So pi is equal to RCT. Will we have used universal gas constant only to remove the, yes, to remove the proportionality sign. So we got the formula for osmotic pressure, that is pi is equal to CRT. Now how you calculate concentration? So number of moles divided by volume into R into T. So remember that, guys, here we use molarity instead of molality. So here we are using concentration as molarity. Remember it. Okay, so we are using molarity for the concentration, and yeah, this will be the formula. Now number of moles also I can split it up and get the formula. So pi will be equal to WB by MB, yes, into RT by V, and that's what you can relate as a formula. Okay, very good. So if you want to calculate any particular thing, like suppose if you want to calculate the molar mass, so molar mass, what you will do, you will take this side, and molar mass will be WB into RT divided by pi into V. Simple. Okay. So this is the formula by which you can calculate the molar mass. Actually, by all the qualitative properties, guys, you can get to know about the molar mass of a solute. Okay, you can calculate that. So we have a different formulas, and by which we can just utilize them and get the molar mass of the solute. Okay, and all the qualitative properties helps us to do that. So yeah, let's just do one question related to the osmotic pressure, and let's see who and all will be able to do it. So the question is here. All of you try to get the answer. Let's see who and all will be able to do it. A 200 centimeter cube of an aqueous solution of protein contains 1.26 gram of the protein. So they have given the mass. The osmotic pressure of such solution is found to be such a solution at 300 Kelvin is found to be 2.57 into 10 to the power minus 3 bar. Calculate the molar mass of the protein. Simple. Calculate the molar mass of the protein. Yeah. So you know that 200 centimeter cube is given to you, which is nothing but the volume, which you can write as 0.200 liter also. Contains 1.26 grams. So you can relate that they have also given you the mass of the solute, and the osmotic pressure is given, temperature is given, pi is given, and you have to calculate molar mass. So you can relate that WB is given, R I can utilize according to what pressure unit they are talking about. So they are talking about osmotic pressure in bar, so I have to take in bar units only. T, pi, V, everything is given, so I'll be just multiplying it. Correct. So what will be the MB? MB will be nothing but you will be having the values which we can relate. WB is 1.26 into the R is 0.083 in bars. Temperature is 300 Kelvin divided by, you have osmotic pressure 2.57 into 10 to the power minus 3 into, you have the volume 0.200 liter. So you will be solving it and you will get around 61,022 gram per mole. So yes, all of you can check and let me know later on that whether you got the same answer or not. So this was about, guys, what we discussed. We discussed about two validative properties today. One is elevation and boiling point, that whenever a non-volatile solute is added to a volatile solvent, what happens, guys? Yes, what is seen, that the boiling point increases. And how we can find it out, we learned the formula, how we get it, and also we discussed a problem related to it, and we discussed osmotic pressure, about that it's also one of the colligative property, which is nothing but it's the extra pressure applied on the solution side, so that these solvent to solvent molecules, solvent to the solution side flow of solvent molecules stops, and that's, we call it as osmotic pressure. How we can calculate that, that's what we have studied. So make sure, guys, you are solving the problems related to it, and if you get any doubt, do let me know in the next session. So guys, like the way we have sessions on YouTube, we have also session on our Unacademy platform, and there are special classes which are absolutely free for everyone, so you can come there and learn the topics in detailed manner as well. So yes, guys, so make sure you are solving the problems related to it, and if you get any doubt, do let me know in the next session, or you can let me know in the comment section below. Okay, so okay, guys, then we'll be meeting in the next session. Thank you, all of you. Bye bye, guys. Thank you, everyone. Thank you, guys. Bye.